In the previous video, we learned how to draw the symbols for some electrical components, such as wires, switches, incandescent light bulbs, cells, and batteries. Also, we learned that there are two agreements for electric current flow, and, for this series, we adopted the so-called conventional flow, since it makes life a bit easier when explaining electrical circuits. We are going to start this video by talking about diodes. A diode is a component capable of conducting electrical current in one direction only. If the anode, triangle in the symbol, is positive, and the cathode, bar in the symbol, is negative, the diode conducts as if it were an on switch. Let's look at a simple circuit using a battery, a switch, a diode, and an incandescent light bulb. The anode of the diode is represented in the diagram as a triangle and the cathode as a bar. With the polarity shown here for the diode, whenever you turn the manual switch to on, the diode will conduct and the bulb will light. However, if we reverse the polarity of the diode, even if we turn the manual switch to on, the light will remain off. Next, let's look at another component. The resistor. A resistor is a component that has a built-in opposition to the flow of electric current. In our case, this is a small half-watt resistor, which is built in such a way that it has an opposition value to the flow of the current, preset at 2200 ohms, being an ohm the unit used to measure the resistance or opposition of a component to the flow of electric current. The symbol for a resistor is a broken line. The resistance value in ohms is usually noted on a schematic diagram next to the resistance symbol. The quantity can be written in full or abbreviated, using the letter K to indicate thousands of ohms. Now, we are going to consider another widely used component, the LED-type indicator light. The name LED comes from the acronym for light-emitting diode. This particular type of diode produces light when an electric current flows through it. Unlike incandescent bulbs, it is much more efficient. However, being a diode, it requires the proper polarity, anode has to be positive, cathode has to be negative. In this example, we show three common colors of LED bulbs, red, yellow, and green. Since we are now acquainted with this type of light source, we can now draw another simple schematic diagram, consisting of a battery, a manual switch, an LED bulb, and a 2200 ohm resistor. The resistor must be included, because LED lights are built to withstand a maximum of 3 volts. If we connect it directly to the 12-volt battery, the LED would burn out immediately. Now, when you turn on the manual switch, the LED bulb, in this case yellow, will light up. The last component that we will take into account is the so-called relay. The relay is a switch, which can be operated remotely by applying a small current to its coil, which energizes an electromagnet, which, in turn, closes its heavy-duty contacts, and a much heavier current can be controlled by such contacts. In addition to this, a single relay can handle several groups of contacts, being able to turn on one load and turn off another at the same time. Or else handle circuits which require various voltages and currents. For our next schematic, we are going to use a battery, a manual switch, a relay, and a high-intensity bulb, say, a 400-watt incandescent bulb, as in our example. By applying a very weak current, a fraction of an amp, from the 12-volt battery, to the relay coil, the relay contacts will pull together, thus turning on the incandescent bulb, which uses a much higher voltage, which can be 220 volts from the electricity company, with a heavier current, close to 2 amperes. We are done with this segment, and we invite you to follow the series, and, please, subscribe to my channel. Regards.